Identerati Office Hours. I'm your host, Mike Schwartz, founder of Glue. And today we have Ahmet from Tyke, who's the head of R&D. And we have Jacob from Curity, who is the CTO of Curity. Welcome, Ahmet.
Hi there. Thanks for having me.
And welcome, Jacob.
Yeah, thank you. Good to be here.
So the idea for this episode came from watching a YouTube presentation from Kubecon that Ahmet presented. And so I was interested to give feedback because towards the end of that session, it seemed like you started struggling a little bit. And I thought it raised some really interesting questions. So maybe, Ahmet, you could just give us a quick summary of what you were trying to do there and how it went.
Yeah, sure. So Tyke is an API gateway, and as an API gateway, we are often at the very front or at the edge of the customer's infrastructure. The gateway is deployed there, and often folks authenticate using an authorization server like Curity or Glue, and obtain or keycloak in the use case. In the case of the Kubecon talk, they'll authenticate, authorize themselves, obtain an access token, and then the browser or the client within the browser will use that access token in order to access protected resources inside the customer's infrastructure. Now, that access token arrives at the gateway, and the gateway needs to validate the access token and then do something with it. So perhaps extract some claims from the access token, like what the user's name is, what the user's ID is, and then what their role is within the organization, or what their rights are, and then somehow pass those on to the resource servers, so that the resource servers can make some kind of decisions within that microservice architecture. Now, the problem that we were trying to solve is that inside a microservice architecture, the request goes through multiple chains of calls, and I'm trying to understand how we can enable the gateway to perform its authentication and authorization of the request without being like having godlike capabilities. So how do I ensure that it's only able to access the services that it's allowed to access? And how do I ensure that it's only allowed to perform the correct kind of operations which the user delegated when to pass their identity and their authorizations through to those services? So I guess that's a high level overview of what I was trying to do.
And in your demo, so let me just understand. So your client was taking, for example, maybe an ID token and saying, I have an ID token to authentic that identifies this person, and I want to take that ID token and get back an access token, which I can then present to APIs in order to get authorization to call certain APIs. Am I right about that?
So during the OpenID Connect flow, the client obtains an ID token and an access token. And my understanding is that the ID token belongs to the client, and the access token is the thing that you're supposed to be using in order to access the protected resources. So if you look at the audience claims of the ID token, it will be the client, it belongs to the client. It shouldn't be shared outside of that particular client that ID token was issued to. So then that client is free to use the access token to access whatever services, and that access token will have an audience. That audience might be this token belongs to or can be read by this particular API gateway that's at api@foo.com or something like that. Now, if the gateway is the intended audience, then should the gateway be passing that access token around? And that's why I was looking at the token exchange, because then the gateway can exchange the access token for another access token with a different intended audience.
Yeah. And just to clarify, the access token that is returned to the website or client after an OpenID Connect authentication, the audience for that is the client that requested it, but the intended recipient of that particular access token is the OpenID provider, because normally the access token that's returned to the website says, okay, we're going to allow you to call the user info endpoint to get information or user claims about the person, because user claims aren't in the ID token, although they can be in some cases. But technically, an ID token tells you the details of the authentication event. So that access token that comes back from the OpenID authentication is to call user info, not to call other APIs per se, although I guess it could. Jacob, can I pull you in on this? What is your thoughts on
Yeah,
how
I don't know if
broadly
I
that
fully
access
agree on
token is
that.
used?
Yeah,
Sure,
yeah.
go ahead. Yeah,
I mean, if you request a profile scope when you do an OpenID authorization
right,
request, then of course you can call the user info endpoint. OpenID scope plus profile scope equates access to the user info endpoint. And audience-wise, I mean, audience is an array, or can be an array depending on the
right,
format of the token. Let's say it's a JOT, then the audience could be an array. So obviously you can have multiple audiences in there. One of them could be the user info, but then the others could be other research service that you want to use. But the way I typically see it is, when you look at the scope request in general, is that if you think of scope as scope of access, what am I requesting here to be able to access? Then the gateway has a pretty important role to pop open the token, look at the various scopes and see, okay, you can go to these APIs or those APIs. So scopes in combination with audience is a pretty powerful way to sort of let the gateway do the coarse-grained authorization that it can do early on. And to some extent, it could perhaps do also finer-grained authorization decisions depending on what it knows about the underlying resource, right? So, yeah.
right. It's a really good point. And I'm putting into the chat I love Google has this list of all the scopes for all their different APIs. And right, so a subset of those are the OpenID scopes like profile. So it's a great way to explain it. Yeah. So, and I think you start to see at some of the complexity we get into here, and like what type of access token is this? Well, it depends what was requested and what was granted. But let's just go with this. So you have a person who's authenticated, right? And as you said, this ID token and access token are probably scoped to the client, and you want to take this and call another API with a different audience. And I guess, Jacob, let's forget about the fact that they probably could have just had the right audiences in the first place. It sounds like that's what you're saying, right?
Well, if it's a big system behind, no, that maybe the audience is the gateway, but the gateway has a lot of other audiences behind it, so it still makes sense what Ahmet is trying
And
to do here.
this is the challenge with a microservice architecture, which is the whole reason for the talk. One API call might result in 3, 4, 5, 6 other internal chained API calls. And so how you can't expect the client up front to know which services it's going to need to be communicating with. So those, and that's the reason why those audiences potentially need to be dynamic if you want to be able to do it kind of properly. And so that's why I was thinking that maybe the token exchange could solve that problem. Or I mean, I'm assuming that's what the token exchange is for, so that you can then almost like exchange the token, and you're not then passing around one access token amongst all of the different microservices as well. Because by doing that, you're reducing the security, or you're saying that the gateway is allowed to, this particular access token, if you're sharing it, could do multiple things like take payments or make payments or something like that, and which is pretty serious kind of security risk, right?
And maybe now if I could I quickly share my screen and we could just talk about what a token, OAuth token exchange request looks like. So I realize this is because I had to sort of look it up. Like it's been a while. Maybe I just have a bad memory, but I forget how these things work. Um, so I went to the RFC and I did a quick sequence diagram, and I think that it raises some of the complexity. I don't know, from my perspective, token exchange, it raises a lot of questions that maybe couldn't be answered at the time, and it's like almost like a first step. Jacob, how do you feel about that? And you were talking about the evolution of token exchange. How do you feel about sort of like where it started, where it ended, and maybe what questions it raised that are better answered by maybe some other architectures?
Yeah, that's a good question. I mean, token exchange, or put in other word, exchanging tokens is a very convoluted topic. There's a lot of, when you say I need to exchange a token, the prerequisites of that can differ, and the spec here talks about impersonation and on behalf of a delegation as the sort of things it's trying to solve. But impersonation in many people's minds are user impersonation. I want to impersonate another, like my child, and do something for that, or I want to be delegated access to do something on my child's behalf. But and that's a bit where the token exchange spec started, but where it ended is more of what Ahmet is trying to do, actually, which is more service A has this token, but now it needs to, I need to take over this token and send it somewhere else. So I'm going to impersonate the original client, but I'm going to put myself in there as a paper trail that I'm now the one doing the next step, and that's where it landed. But it's a really open excuse me, it's really open-ended specification. I mean, policy-wise, it's very hard to generalize token exchange. You have to kind of figure out your use case and go and solve that, I think.
Yeah. And I wanted to bring up, I was perusing the spec before, and this sort of jumped out at me. But the reason why I think it's so difficult is because it almost combines the complexities around trust management and also authorization management. And in the spec, it says, okay, after the authorization server gets this request, it must perform the appropriate validation on the tokens, of course, right? And there's your trust problem. But then it says it also must perform the appropriate validation for basically the requested resource and the requested audiences. So it's almost like we're trying to load into this one little spec, basically trust management and authorization. And how is any AS supposed to do that?
No, exactly. That was my point too. That thing right there is, a PDP and a policy language and all of that baked into a sentence of what you're going to need.
And a federation server. You know how I think the OpenID federation specs like on draft 85. So it hasn't been an easy task
No.
to do it. And the tools that they give us here are, okay, when we make this request, first of all, this is a request at the token endpoint, which implies some type of client authentication, right? And that's sort of like, they don't really say what type of client authentication is required for this. Maybe you're presenting a token for the client authentication in the first place, right? Mm-hmm. Anyway, and then you specify the grant type, fine. You say, okay, the type of token I'm going to give you, let's say that's an ID token or a SAML assertion. So there's a subject token type, which I believe is required. So subject token type and subject token are both required in this spec.
Yeah.
So it sort of implies that this is an identity assertion. I guess it could be an access token too.
So in my example of Kubecon, I used the access token, not the ID token.
Okay, so when you posted the subject token type, you posted an access token?
Correct, yes.
Okay, so you're saying, I want to trade an access token. And what was your requested token type there? also an access token?
So I didn't use that. So I used Keycloak for the demo, and I think it automatically gives you an access token. So
Right.
I didn't
Right.
see
And
I didn't see the ability to control that or configure
this
it
is
that
an
way.
optional parameter. Yes.
Yeah.
And then so the subject token type. Jacob, just out of curiosity, Curity is an awesome OpenID provider and an awesome AS. What type of, in the token exchange implementation that you did, what type of token types do you actually support for subject
Well,
token type?
we support, out of the box, we support access token actually, because there's a few cases that are pretty common, and that is down scoping and down audiencing. So you have an access token, but I want to strip it. But I can't add stuff. I just want to strip stuff so that it's less powerful when I send it to the next
Sure.
one. So that we support out of the box. But given the complexity of what we can do with this spec, we decided to implement this as an SDK. So we support all types, but you plug it. So you say, I'm going to take ID token, and we can validate, we can do all of it, but you're going to have to implement the policy around that because it's so incredibly custom. But a pretty common scenario is like, I got this token from another AS, and I want to exchange it for my environment in my AS. So say that I got it from Google or so, and they send it to us, and we give you one that is Curity. That's also a pretty common case. But so yeah, that's where we started. That's where I see so I'm kind of similar to Ahmet's cases is the cases I see. Like you want to impersonate things inside the network very often.
Yeah. But so and you don't accept ID token as a subject token type?
Not out of the box, but we do. It's acceptable, but you have to plug it. So you have to write the procedure around what's going to happen if you get an ID token.
I see.
So the answer is yes, but you have to do something with it, because out of the box there's no default behavior of what do we do when we get an ID token. Because I don't like that type of exchange. I can see the SAML token exchange more relevant, because it's like you're going cross protocol. But yeah.
Right. You know,
So what you're saying is to exchange a SAML token for, say, a JSON web token or something like that, and is that what you're saying?
For
an access token, for instance. Yeah.
Okay.
I think that use case was really near and dear to their hearts. How do I exchange a SAML token, an identity assertion, for an OpenID identity assertion, i.e. an ID token? I think that was definitely one they were thinking about. I'll tell you weirdly, because it seems that, we've looked at 3 OPs, because Ahmet used Keycloak in his demo, and we have Glue, and we have Curity. Believe it or not, and I didn't know this until like yesterday, or I knew it and I forgot it, but in the Glue server, the subject token type must be ID token, and we validate that ID token. There's the trust part, and then we return you an access token. So our primary use case was, we don't want to see, we have maybe a client that doesn't want to just send the ID token. Jacob, let me ask you this, just from your experience, because I know there's what you should do and then what API developers actually do are 2 different things. Do you see API developers sometimes just sending the ID token in the body as a request of the request for an API? Like, what do you see in terms of? Yeah.
I mean, yeah. It's it's like, here's a JOT, let's send it. I had a talk a couple of years ago at Nordic APIs about JOTs in general, because I mean, if you're misusing the protocol, you're kind of driving a car with no traffic rules. I mean, what's the safety around it? How do you know it's going to be, nobody's going to crash into you? And it's kind of same with the protocols. If you're sending the ID token or just don't care about how to use it, then all the security that's built into the protocol is gone. Like you can't trust anything anymore. So yes, I do see it, and we do have that conversation here and there. Like, wouldn't this be nice? And it's like, well, don't, because there's a reason for things being the way they are, right?
Yeah.
And I guess,
Yeah.
I mean, is it possible to refresh ID tokens or log out an ID token? Can you introspect that? Because this is not my world. This is your world. I feel like
Yeah,
the
a
access
refresh.
token is better for that use case, right?
Yeah, I mean the ID token like Mike was saying earlier, it represents the authentication event. So a refresh could be that you again go to the IDP but get single signed on in and get a new ID token with additional details. It could still represent the original event, or it could be updated with details. Logging out, there's a logout spec. You don't typically need to send the ID token necessarily. I think you can. I don't remember actually. That logout is always an area where the specs really don't work that well, I think. But yeah, you can send it to the IDP in some cases. There's also the ID token hint parameter that you can use sometimes when you want to communicate with the OP and say, based on this previous event, do this. So that happens in some cases. SIBA has that, for instance, and I think the core spec allows that too.
I actually want to highlight one of the optional request parameters in this spec, which is resource. A URI that indicates the target service or resource where the client intends to use the token. And this is where I'm saying it sort of seems like it's getting into the authorization space. So we're presenting tokens, and how do we validate those signatures is just sort of assume that somehow we know how to validate the token of the signature that was presented as the subject token. But then there's this other parameter in here that I don't know that anyone would know how to support this, but the implication is that that you could actually give the AS information about the resource, and based upon that, they would make an authorization decision too. So I don't know. Do you guys support that at Curity?
No,
I
mean no, we don't either. The resource indicators are, I think they're a bit redundant given audience and scope, but there are cases where, of course, where they could be useful, but we didn't ever think that was important enough for us.
Okay, so let's get back to Ahmet's use case before we get too distracted. So poor Ahmet, the API developer, is he just wants to call an API with a token that has the correct audience for the service that he's calling. Have I gotten that right, Ahmet?
I want to access my bank.
Problem?
Yeah, I guess I want to be able to. If I'm trying to log into my online banking and I authenticate with my bank and I want to be able to make a bank transfer, I don't want to. I want to know that I suppose I don't want to. The app developer needs to know that his app hasn't got the rights to view somebody else's bank account. So it's about passing those rights or those delegations through a chain of different services that might receive tokens.
That's a very good point. Like, you don't want the API to turn around and call whoever called it back or something like that. So it's important.
So I mean, if for any reason any service is compromised or has been misconfigured, we don't want there to be any risk of. And I think you made a good point before, Jacob, where you were speaking about downscoping. So just because the gateway is in a very, very privileged position because it can talk to all of the services inside the infrastructure, inside the organization's infrastructure. Just because it can talk to all of the services in the infrastructure doesn't mean that any client should be able to call any service, and it needs to be able to protect that based upon certain claims within the access token. Based upon certain claims within that access token.
And okay, so Jacob, you mentioned that token exchange is not the only way to downscope or to exchange tokens. What are some of the other ways that you were thinking about?
I mean, the other prominent way is the JOT assertion grant, where, but that's more for when we talk about user impersonation or delegation. Or even the SAML use case, actually, because you can provide it. But in the JOT assertion grant, the call or the client creates or gets. Did you guys lose me there?
We lost you for 1 second, but go ahead. Jacob was saying, are you back, Jacob? Sorry. Okay, perfect. Yeah, and
Something
so
is-
I'll just
yeah,
summarize
let's go.
quickly. You said that there's another flow that we could use, but I have a question for you, Ahmet. Why do we need to send tokens to the backend services? If the gateway is trusted, couldn't we just send the JSON payload itself? Why do we need to send that backend service a actual signed JOT?
Okay. Why, if the gateway is trusted? Because we're talking about zero trust architectures, and we're talking about the fact that it's very difficult in, I suppose, particularly with cloud native, in the cloud native world and the consumption of third-party SaaS services, to even understand where the boundaries are. And so, yes, you can ensure that the request came via the gateway, but then are the requests going out? What's being shared externally? Because you're interacting with third-party services. You're talking about leaving your network, coming back into your network, and things like that. So you need to retain a little bit more control. And that's why zero trust is so important. Zero trust approaches is really important these days.
Okay, I think fair enough. So then my next question actually maybe is somewhat related. There's two ways to send tokens in OAuth. We could send a value token like a JWT, or we could send a reference token or an opaque token. It's actually better for security not to send the reference token, because if it leaks, or when it leaks, as people say, you haven't leaked the payload. And so why, or is it maybe, was it possible to use reference tokens? And what is the requirement to use? I mean, if we're doing zero trust, shouldn't we use the more secure tokens? Why are we sending the JWTs? And
Is
maybe
that a question
Jacob,
for
you want
me?
to?
Yeah.
Yeah,
I
can
I
jump
know
in
that
on that.
Purity
Yeah,
is the phantom token expert. So yeah, why don't we talk about that?
let's talk about that. That's interesting, because the ref token that you're mentioning, it's very handy on the internet where you don't want leakages. But every time you want to look at it, which is on the gateway, in the API, all of those places, you have to call the authorization server with what's called an introspect call. So give it the token, and back you get the JSON payload of this is what the token looks like. Kind of looks like the payload of a JOT as well. But so there's a every time you have to do that, because extra request. That's great. But once you hit the gateway, you want to transform that into a JSON web token, so that once you hit the API later on, and that sends it to another, or however you do it behind there, you don't have to introspect it again. Instead, they get the same token, but in a JOT format that they can pop open and verify without additional calls. So we call that the phantom token flow, that you kind of have the phantom going out on the internet, and once it hits the gateway doesn't introspect, but instead of JSON payload back, it gets the JOT back. The same token, but in JOT format. So now Walker comes, and then you send that, and the gateway can cache that. And there's a variant we call split token, which can be used in CDN scenarios too. But that protects you on the internet. But should also say there's another funny sort of protection that you get that is not security. Any developer who sees a JOT, first thing they do, open and look in it. And perhaps start depending on data that's in that token. And like you mentioned in the beginning, Ahmet, the access token is not for the client. The ID token is for the client. The access token is to be sent to the API. So the API and the gateway should be able to open it. The client shouldn't, but it can, because it's a JOT if you're sending JOTs. So they will start depending on the contents of the JOT. And if that changes, all of a sudden 500,000 apps break because they popped open a JOT that they shouldn't have popped open, right? So that's not really a security issue. It's more of a pain that can happen. And I've seen, and that's caused real problems when upgrades were needed and more data had to be stuck in, or data disappeared because they didn't have it anymore. So claims disappeared from the token and so on.
So it would be more secure to use reference tokens everywhere. If we're doing zero trust, we should use the more secure tokens, not just on the internet, but also on the internal network, right? But you're saying it's not feasible because in a microservices architecture, we don't want to have any dependencies on network or persistence. And so the only solution we can think of is to use JOTs on the internal network. But do you agree that it would actually be better, hypothetically, to use reference tokens even on the interior part of the network in a zero trust architecture?
Yeah, I mean, less chance of PII ending up in a log somewhere or being sniffed and exposed on the internal network as well. So sure, I mean, there's that.
Right. Although it wouldn't really change because that reference token would still have a JSON equivalent. And that's sort of what we're talking about here in token exchange. What would be in that? The audience and the scopes and upscoping and downscoping. I have sort of a silly question. Why do we need to do token exchange here? Couldn't we just request a new token from the token endpoint? Like, why have the extra work of the token? If I have one access token and I'm exchanging it for another access token, why bother? Why not just make a straight request for a token in the first place that you want?
I guess in the example that I did, I was actually I authenticated with Keycloak, and then as part of that authentication process, it redirected the request, ensured that I was also logged in via Google, but I obtained a Keycloak access token. So when my client accessed the gateway exchanged that token internally for a Google token, and then I was able to access my calendar. So in that kind of flow. So so that's why I had to do the token exchange, because the gateway needs to know who I am and it needs to be able to access my calendar on my behalf. Whereas if you log in, it would need to be able to access your calendar, and that's how it would need to be able to do those. That's why it needed to do that exchange. How would you grant access to your calendar without the exchange? The gateway would need to have the ability to access everybody's calendar in Google, regardless of the authorizations of the end user who logged in the first place.
I see. So you're taking the so you logged into the IDP, in this case Keycloak, and then you want Keycloak to call a Google API for you. And so in order to
the gateway
do that,
calls the Google API, but Keycloak handles the authentication with Google's with Google.
So you already have a Google session at that point, you're saying? And then you call and so in your Kubecon talk, you ran into some challenges at the end. What were those challenges?
The challenges, this was particular with some particular things with the Keycloak implementation. So themselves, it's really complex to configure. I'm not an identity expert. I don't think, apart from the folk, you guys on the call are the identity experts. And so to configure Keycloak to be able to do this it's not a simple task. It took several days just to prepare that demo. So from a usability perspective, it was really complex. And there's something that I think the guys at Keycloak are actively looking into improving that whole experience on how to create policies around that. There was also the ability to, how do you go about controlling the audience? Now, I wasn't able to do it. I've been assured that you can do it. The documentation says you can do it. But after several days, like, the whole value proposition of this token exchange is to be able to control the audience of the access token, and I wasn't even able to do it. So that's another challenge that I had at the time. They're also with Keycloak, they don't, they kind of chose, the team chose what they wanted to implement of the spec, and they kind of broadly adopted it and decided what parts of it, decided what parts of it they wanted to implement and what parts of it they didn't. So it's not fully following the spec. So it's a little bit difficult when you're trying to go standards, and then everybody's kind of, I suppose, implementing the little bits that they can or that they want to. So it's not really matured as well as it could be.
I have to say, I have some sympathy for the Keycloak team here, because this spec is so open-ended. I don't know, Jacob, what do you think?
Yeah, I was going to say the same. I'd be surprised if anyone can implement the thing broadly, because not only the spec allows a lot, but the dangers, like if you say that you swap audiences, for instance, like the original token didn't have the audience, now you're adding it, or it didn't have the scope and now you're adding it. How do you know that that's allowed and when? Because you're really, like, to your previous question, Mike, about why do you need the exchange in the first place, is like the original grant happened. The user approved something by logging in and saying this system should have access to that. Maybe they even consented on a consent screen. And then that token was issued. And now we want to transfer that grant into another token that we can use further down. But we want that chain to be set together. And if token exchange messes with that and adds stuff that the user didn't grant originally, that's maybe okay, because we know it's a subset of permissions anyway, but it's just called different things. But it may also not be. So by doing a very broad implementation and letting you do anything, you also open up the box for very insecure systems of, unless you know these details very well, it's easy to do it wrong and create really big security holes.
Yeah, and just so I sort of was drafted out a quick sequence diagram on token exchange, and this is what the AS has to do: validate the subject token, whether it's an access token, an ID token, or a SAML assertion. Then they need to validate the actor token. This is another token you could pass in the optional token. And then they have to look up the policies and say, okay, now I know I have these two tokens. Hopefully I trust them. What do I do with them? And then I have to mint a new token and then send the response. And so when I think of Keycloak, I think of like an IDP that has good out-of-the-box functionality. There's an admin console that allows me to do some out-of-the-box things that typically work groups need to do. And so a lot of these things, like validate the subject token, validate the actor token, look up the policies, like how do you build an admin GUI for this in Keycloak? Because remember, Keycloak's always about out-of-the-box functionality. So I guess I'm curious, Ahmet, what actually would you want to see in that? What features did you want to see in Keycloak that they didn't give you?
I guess it wasn't so much about the features. I guess it was more about, okay, how do we make this happen? And rather than kind of blindly following instructions, I felt like I wasn't guided and understood what I was doing. And this is something that Jacob mentioned before. It was like, if you misconfigure something, you open up a massive security hole. If I don't understand what I'm doing, that's a lot of responsibility, right? And that's where I wasn't feeling comfortable, because hold on a minute, I'm supposed to be increasing my security posture, not kind of just copy pasting, following a document, and hopefully it kind of works. I need to have a lot more confidence, and that's the bit that I felt was missing.
And you're basically one of the gurus of API developers. And so I guess maybe we'll finish on the last 5 minutes on this talk. Jacob, are you worried when you hear basically one of the world's API leaders feel like he was sort of not really given enough guidance on how to do this?
Yeah, well, I'm not surprised because of the complexity. And yes, I'm a little bit worried setting these tools out because it's so easy to do it wrong. I mean, that's why we chose the super restrictive way in the default behavior. Like it can only reduce tokens, not do anything else. And probably similarly for you with ID token exchange there, where it's a very fixed set of things that it can do. Because if opening that up is dangerous, but sometimes necessary. So so I guess the question for Ahmet still is, like, because that power is needed sometimes. And I mean, you had the problem that you needed to solve, and it made sense. But how, I guess we need a UX expert on the call as well, probably, on how do you communicate that in a way that makes sense? I don't know. That's really hard.
Yeah, and I think people forget that OAuth, they think of 6749, the OAuth RFC, but actually OAuth is about probably 24 or so plus RFCs, plus all the OpenID stuff. There's OpenID Connect itself probably has like 5 or 6, and then there's all the Jose and the JWT and everything. And so I think people they forget how big OAuth really is.
Yeah.
And also one other thing I would caution you is that OAuth sometimes just provides the common denominator of what people could agree on or what they needed to standardize for some reason of interoperability, not necessarily a fully fleshed out solution. So OAuth is then frequently profiled in federations or by other protocols like OpenID Connect in order to make something more useful that then implementers could then make a consistent UX for, as we're pointing out. So you have to be careful because OAuth sometimes just gives you sort of a hint of like, this is something we've agreed on, but just because you support, like Curity and Glue both support, and Keycloak, we all support token exchange, but a little bit differently, but still within the bounds of like what it says, the spec says we could do.
That's very true. I mean, it was never meant to be interoperable. It was meant to be guidable, I think.
Right, and that's a very good point. And that's why we need profiles and trust frameworks, etc.
Yeah.
Ahmet, how was the feedback from the talk? Like, did API developers tell you they're struggling with the same things?
So I can't bring myself to watch the talk, but the Q&A at the end, someone, I don't know if you guys are the same when you speak at conferences. I don't like the sound of my voice. So, but someone came up and to ask a question. And they said, "This is exactly what this is the problem we're trying to solve." And so, overwhelmingly positive feedback, and folks do want this. They want to solve this problem. I think they felt that it's not ready yet, and obviously, my implementation was a proof of concept. It wasn't a bulletproof plugin that's generally available. And we saw, because it was Kubecon, and that's a CNCF project. That's why the demo was with Keycloak. That's why I used Keycloak for that particular talk. I think they're wanting to solve this problem, but they're aware it's not kind of ready yet.
Okay. Sorry, my background. We're still learning on Identerati office hours about how to run this livecast. So, well, I want to thank Ahmet. Thank you so much for joining us today. And,
thank you for having me.
And Jacob also, it was great to have you. I hope we can do this more often. And
Absolutely.
if you, in the future, if any of the Identerati alumni want to join the conversations, you can send me a back channel conversation on LinkedIn, and hopefully our producer Anish Lambda will see it and let you join. But we want to make this an interactive and regular event every Tuesday and Thursday. Thursday at 12 p.m. CST. Tuesday, we're going to try and move the times to include some better times for APAC audience. We're planning one at 9:30 IST coming up in a couple of weeks. So thank you guys so much for joining. Thank you, audience, for listening. Please post your comments and follow Identerati Office Hours LinkedIn to get the latest events. Thanks, guys.
Thank you.